Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
And this is Fred Schenkberg. Hey, Kirk.
Hey, Fred.
Hey,
good to hear your voice again.
Yeah, we recorded yesterday. We're recording today. We're on a roll here. But, hey, I got a topic for you. It came up to me this morning.
Okay.
And it was a question of, there's there's the change at the time we're recording this, there's restrictions on oil transport through the Strait of Hormuz. There's uncertainty in political realms. There's all this different stuff going on, and there's inflation profiles. And so this person is in a company that's saying, we're scrambling because we use stuff that comes through there and we can't get it. And it's, impacting our supply chain, and everybody's focused on that. And nobody wants to look for a new job, and nobody's hiring. And it was like, and I get like 800 emails a day. How do I keep reliability how do I keep reliability, the work to create a reliable product, important? How do I compete with all of this noise that's going on? And I thought, I never thought of it that way. For me, reliability is always important.
Yeah, it's right. It's again, reliability is sometimes an afterthought, and it is in many companies a low priority in the development stage, and that's one of the big problems. Is it's always been, because many times you can design a product and without HALT or HAS or even testing it, if you follow some good design rules, it comes out pretty good. It comes out pretty reliable.
You get lucky sometimes.
You get lucky, yeah. I mean, but not, and companies that have experience in developing hardware don't always come up with a latent defect in their products, and certainly learn once they do, and it's cost them. And that's when they, really focus on maybe prevention. But many go a long time without failures, and so it's again, just like once you have a robust design, it is difficult to keep reliability important in the manufacturing because I don't know if you've developed HAS screens or and there is a period of time that you shouldn't be still seeing defects. You should have weeded most of those out, or the causes in manufacturing, which is really what you're doing in a HAS test, is looking for flaws introduced during the manufacturing process, because through HALT you should have developed a robust design that had plenty of margin, or certainly the margins available with standard materials. And you shouldn't be seeing, so, but if you do keep running the HAS test when your product has kind of become matured and it's very low failure rate in the field, then, it is questionable whether it has a real significant added value or you're getting a good ROI.
Right. And I've heard that argument before, and I've seen where people say, it was a long time ago when burn-in was considered the thing to do.
Right.
And it was, we're doing HAS, it's a little quicker, and we always do it on everything all the time. I was like, why? You're not finding anything. You're burning all this electricity and time and delay, and you're not getting anything. And so, we always do it. I'm like, well, okay, if you got the money, whatever floats your boat. But in this circumstance, I would, if you're got a mature product, everything's going, and then all of a sudden you have to shift to a different supplier or a different manufacturing site or stuff like that, bring that old numbers together because that test will help you identify what
Exactly.
those changes of
Exactly.
where they've wreaked havoc. I wanted to work that phrase in here somewhere.
Havoc. Yes, introduce something that produces havoc in the field. Yes,
Yeah.
it does.
Well, that might be a whole nother podcast because I can see the title now. It's like, oh, it's the same form, fit, and function.
Yeah, exactly. But that's where going back and, once you've established empirical margins, you've actually observed
Hmm.
where the product strength limits are. And that's again a challenge to get people to get engineering to do that because they all complain that it's way beyond it'll ever see that in its in use environment. But once you've established that in your development and you had to have a supplier chain, then you would take that component, that material, power supply, whatever you have to do,
That
whatever
system
change
there.
you make, and put it into the product as it's established or what to put that replacement in, and then evaluate it again and see if it has the same margins, the same voltage margin, the same thermal stress
Yeah.
limits. And if it does, it might even be better. That'd
It might
be
even be good. Yeah,
surprising.
you'd be
Yeah,
really
yeah.
good.
In
I've
that
rarely been
time, yeah,
surprised with that,
yeah,
you know.
yeah.
Yeah, you spend 6 months picking the perfect power supply, you do all this vetting and testing and evaluation and design
Right,
work, and then you got 2 days to find a new one. Yeah,
right.
you might get a good one, but you might
Yeah.
not.
Well, and that could be why, one of the things that I always talked about is using stress tests to compare competing suppliers for the same component or device that you need, like a power supply, which is pretty
Mhm.
common. And of course, in PCs, the silver boxes was always, required, and there were several different suppliers to choose from.
Mhm.
And so we put those through a test and, found the significant differences in the margins on each power supply.
Yep.
And
So
obviously
you would have a preferred one then,
you're right.
but you were making so many of them, you still needed to be able to accommodate the other ones. And
Right.
so but I'm thinking of there's two parts to answer this question. One is
Hmm.
when there is disruptions to your supply chain or just cost pressures that you need to do cost cutting somewhere, and it might reduce use different components, and it's a difference in your supply chain.
Hmm.
Is that almost always, and I have rare exceptions where those changes actually are benign or have no effect on the reliability performance. So what you just outlined is a great way to check that, to make sure that the changes are safe or are not going to harm the
Right.
reliability. The
Right.
second part
Right.
of that, though, is somebody says, well, we got to cut costs now. And it is a more difficult argument to say, well, if you save a nickel today and we pay 50 cents per unit that you put this in later, we're going to go bankrupt. you know, if you
Yeah.
save a few pennies today and none of your power supplies work in 3 months, we're still going to have to pay that number. But the argument I get back from folks is, well, I need to pay the bills today. And if
Right.
if you're in that dire of a straight, and you can't look ahead 3 months or 6 months, then yeah, it's get your resume together because they're going down the tubes. But it's also then find a good finance person or find another champion that says, this is what's the old saying, penny wise and pound foolish. I think it deals.
Right.
It's
Right.
British money. It only makes sense with their currency. But the idea is that, yeah, you can save a couple nickels today, but you're going to be paying if you don't do it deliberately, such that those savings aren't going to cost you adverse responses later. But you also get, well, we got to save the money. We have to have a supplier to make this power supply work. And we don't have money to test it. And we don't have time to
Well,
test it. And I'm
yeah,
like,
that's
it's a hard one to go over the top of, but you got to
right.
find somebody to help you say,
Yeah.
no, we have to be in business next quarter too.
Right. Right. And what is your supply inventory like? And how quickly you're going to have to change.
Yeah.
Uh,
Well, some companies nowadays, it's like day to day. They don't.
Oh
have
yeah,
any
it's
supply
just
in
in
house.
time.
Yeah.
That's what we learned, just in time manufacturing, where
Yeah, it's
you
just a
had
disaster waiting to happen is another phrase for it.
what was that, the Kaizen system or something? You'd have the
Have the
bins
parts
and
show up just as
flags.
and just as needed. That's it.
Yeah, just as needed. So, but and right, that's so they don't have a lot of inventory ready many times. But as far as having to make changes, that's kind of something that all supplier, usually anybody that's manufacturing for more the same component or same system for more than 5 or 6 years is going to have to change some of the components during that
Yep.
time.
Yeah, and that's a good point. It should be an
Yeah,
established practice of this
right.
is how we assess the risk, and then we move forward. But if you're doing it the first time and you're under a time crunch or this global you know and we had practice during COVID, right? There were bunches of nothing was coming out of China for a while,
Right,
and
right, right. Well, that is a challenge though. Like working at Dell as a reliability engineer, they passed engineering changes, ECs to me to say, ask whether you think that's going to be a risk or anything like that.
Mhm.
It's really hard to tell when they're changing one resistor or resistor supplier or,
Right.
a pretty passive component that just you buy in billions. And you just couldn't test for all those things. The constant EC changes on 12 models of computers or workstations or servers. It's just you just can't keep
That's
up
never
with it.
ending.
No,
Yeah.
it's never
But
ending.
you
So
had that process in place, and enough eyes got a chance to say, "Oh, wait a second,"
yeah,
and you did on occasion.
yeah, occasionally, but the companies those sizes, HPs and Dells and Acer and all the other companies, have to have, usually they're selling the volumes that they had to have multiple second suppliers, or
Oh yeah.
and so they can sometimes when one supply chain is cut off, they can switch to the other suppliers. But
That are already proven out and stuff, but it
yeah.
doesn't apply to every company and every organization.
And the problem is there we didn't get to always do mixed builds where we could check all those suppliers on, if we had to
On all the
change.
permutations. Yeah.
Yeah, all the permutations would be, take hundreds
You'd
of
be there
tests.
forever, thousands of samples.
Yeah,
You'd be there forever.
exactly.
Yeah, no, there's something to that. But the idea is that if you have an established practice in it, that still is relevant. But I think the argument of why do we need to spend the time doing this? We're in an emergency right now is because
Right.
we,
Yeah.
I always framed it as, all right, what if it increases the failure rate by 5%? It's not unreasonable, right? We have plenty of history
Right,
of supply
right,
chains
right.
doing
But
this
you'd only know
changes
that
to,
after the fact.
we only know it
I
after
think.
the fact. If we can avoid that by spending $1,000 today or thinking
Right,
about it a little bit or doing an evaluation,
right.
then we avoid $500,000 of cost later. Is that worth it? And I haven't
Yeah.
found a single manager or engineer or budget person that says, no, that makes sense. But you have to have those numbers. You have to say, all
Well,
right,
yeah, you had
what's
to
the
know it's
impact of your
5% are going to be
5%? But it's just a guess at 5%. It's just a guess at
exactly.
5%. But if it is 5%, it takes some effort to figure out if it's good or not. If it's a
Well,
20% increase in failure rate, then I can test two samples. I could tell you that, or no, 10 samples, and I can tell you that that's a problem or not, right? We can
right,
look at the change
right.
in HALT and say, nah, that's going to be a problem. And
And
here's the
somebody
number.
somebody tells me we're gonna lose 5%, or somebody before they've ever, put it in there. And I say, what is the 5% gonna come from? What mechanism is gonna be
Yeah.
failing?
Yeah. Yeah.
How do you know that? And tell me, where are you getting those numbers? That's what
Oh,
I want to know.
now, I had somebody actually do this once. They had a
Okay.
part and they said, but if we'll save this much money if we use this part, and it'll only cost us this 0.5% change in failure rate for this component. And I'm like, okay, well, it's a low
0.5% fetch. Okay.
change in the component's failure rate, which was
Okay.
already really low. I said,
Yeah.
all right, so how do you know?
Well,
What's the difference?
exactly. Where did you get
And they
that
said,
number from?
where do you get that number? He says, well, we used to use this component. and we swapped it out for one that had a coating on it, so it avoided the corrosion.
Okay.
And our failure rate down, and this is back when they were tracking down to the component level, it went down 0.5%. And so they're going out of business. I can't find another coated one. We want to use this the old one we had, and I know the number now. So I says, well, how many of these things do we make? Blah, blah, blah. All right. How much does it cost when one of them fails? Blah, blah, blah. All right. Let's go get a machine that coats these for us because it would be cost effective to do it. It's like, even though it sounds like a really small number, when you multiply it by 1 million units you're shipping per month,
Oh yeah.
and it costs, it's not like you're replacing just that component when it fails, you're replacing the whole system. It
Yeah.
adds up really quick, and you got to have those numbers handy so you can assess whether that's a real change or not. And everything looked great. It says, we used to use this part, we changed to this to fix this issue. It made a minor change in the overall failure rate, blah blah blah. But it was minor to that component. And I was like, when a component fails, it only costs 10 cents to put a new one in, you
Yeah.
know, but
Well,
it doesn't cost the customer 10 cents to ship it back to us and be without the unit for two
no,
weeks.
I
And
mean, we got the classic case of my, the fact that the aluminum electrolytic capacitor in the Dell and many companies, this has
Mhm.
happened before, where
Oh, is this
the
the
formula was
electrolyte
wrong. Right,
formula?
right.
Yeah, yeah.
But as I've talked about before, and one motherboard, there were 26 of those used, but there were only three or five that were critical,
Hmm.
and it would cause the board not to be able to boot. But when you replace those, even though the other ones were kind of bulging at the top and obviously failing, it didn't affect function of the computer. And so they had to
Until they
replace.
vented, I would replace them because once
Well,
they vent, then you got
well,
this gross acid all over the inside of your
yeah.
board, and it only goes to the worst possible place.
That might be an after effect that could affect them or not. But I, I ran them hours like that. When we replaced the ones that only were critical, and then put the rest of the boards in a 95C environment, just static, but running operating boards.
Yeah, I hope you had safety glasses on.
Well, no, they were in the chamber, so we didn't worry about that. But and we had to put a cooling hood over the CPU to keep the
Yeah,
over temperature protection from tripping.
yeah.
And they bulged in about an hour, the ones that were defective. But again,
It didn't matter.
didn't matter because and I asked an engineer, why did why are all these capacitors here that really, if they fail, they don't affect the. He says, oh, engineers kind of put them in as a safety margin, just to, transients and things like that
Yeah,
they might have, filtering
yeah. Take those
capacitors.
units and do the RFI emissions again, and you probably
Yeah.
won't make it.
Maybe not, maybe not. So yeah, I don't know if they, that's included in the FCC testing that they would have to add capacitors, which they may have to do, but that's expensive,
It
especially
is.
after you've designed the
Oh yeah,
board.
no, that's why they put them in at the start, and then
Yeah, yeah, you might
because the
say
next
right.
program will have more time. We'll do cost reduction. We'll take
Yeah.
off half of these
Yeah.
capacitors.
And that's another aspect that people talk about with this, margin thing. When I first told an engineering manager at Dell, well, we've got, motherboards can run to 135C if we suppress the CPU trip, and he goes, well, we don't need them to run to. Is there some way we can reduce the cost and have less margin? You know, can we buy back some of that margin and make
Only
profit
very
out of
carefully. It's
I
like,
said,
no, not really.
not really. This is kind of intrinsic to the semiconductor to electronic component and FR4 build
If you build it right,
PCBAs.
it'll work there. It'll be just fine. But if you don't build it well, then you're screwed.
Right. And you got some really significant margins. I mean, none of these motherboards that I put into the chambers and test for the first time to the limits, they would, run some of them run 110, 100, and no, nobody had ever done that before, so they didn't know
Oh,
that,
I had one that went to 42 degrees and it failed. Just total failure. Something burned out. And he goes, "Well, we only allowed to use it to 40C. You
yeah,
know,
it's
that's
right.
it. That's
Our
all it's
spec's
rated for."
35, so hey,
35. Oh,
if you
what are you
take it
talking about?
outdoors on a 98-degree day, you're just screwed.
Yeah, no, it's your fault. You know,
It's
like
your fault. You
no,
abused
no.
it.
This should have never failed there. This is actually a pretty bad design and or component. So let's figure out which. And then, you
Right,
know, they did a few simple changes early in this
right,
program. They put it back in the chamber. It was up there to
right,
120, 130
right.
and just humming away just fine. And they're like, wow.
Yeah, I've seen one resistor change and or a diode change. It makes a 30-degree difference
Oh,
in
yeah.
its margin. And if they hadn't gone to the limits, they would have known this. Also, they would know, that they have a huge distribution between three different samples or deviation
That's
in the
right.
limits, and
You
that's
got
kind of like,
20% of your products are going to fail at 35, you know,
yeah,
because
so right,
but anyway, the idea is that
yeah,
we're going to be facing changes, right? And there's lots of pressures on
always, yes,
organizations to do
right,
cost reduction.
right,
In geopolitical turmoil that becomes even more apparent, but it happens all the time. Just normally, companies stop a production line on this
I know,
system or this component gets changed, and oh, we
and
didn't know that would affect you,
right,
and all kinds of cool stuff is always going on. So all of those, the individual weekly changes are just practice for when we really got to focus on
right,
making serious
right,
changes.
right. You've got changes in production locations sometimes, or a contract manufacturer, or there's just all those changes that you have to be aware of, and that's why I say an empirical test, a limit test, is at least one way. It doesn't catch everything. I mean, no one test catches everything. So,
But it gives you a
combination.
baseline to evaluate changes really
What's that?
fast. It gives you a baseline to evaluate a change. If we have
Exactly.
to go with a
Exactly.
completely different power
Right.
supply, or
Right.
for example, you put
Yeah.
it in and you need two samples and you're off and running, you can tell if it's going to be a disaster or not. But
Right.
it's not going to give you the 0.05% change in failure rate kind of
No.
number. It's not going to
No.
tell you that, but it'll give you a red flag if it's a disaster.
Right. You can see if it's if the deviation in like 3 to 5 samples is huge, then that you're going to have, when you produce 1,000 or 10,000, you're going to have some tails of the weakest
Mm-hmm.
one of those, that deviation come into a worst case or even a mild case of stress in the end user's use.
Mm-hmm.
So, that's the whole point is
All right.
the temptation is to take a risk now, yeah, for future, boy, miss that bullet, kind of thing,
Well, it is, and and when
hoping,
there's a lot of pressure
and
on an
sometimes you get it
organization,
right.
and
Sometimes you
sometimes you get
do,
it right, and it's a guess, and you just go with it. But
and you get lucky.
you get lucky, but it's much better to have the evidence and the data, whether you're thinking it through or analytically, or you do it empirically. It You have to be prepared that there are going to be changes. We Next month's going to be a different
Right,
set of changes,
right,
guaranteed.
right,
And so get that kind of system in place and the mindset of just because it's an emergency doesn't mean we have to do it like that. Here's the bigger picture. Here's the numbers. Here's the effects and the risks that we're taking. Look at the
right,
big picture, do good work in the labs and the design teams
right,
and get plenty of margin. You're going to be way more resilient overall. So the
right.
best time to respond to the closing of some supply route is design it with lots of margin, just
That's
to
right.
start with.
That's exactly it. The design with margin has more tolerance for variation in the components generally and the end use environment
Yeah.
stresses. So, margin equals reliability. As proportional to reliability is my view. And
Gonna have
if
to
you
make a
can,
T-shirt out of that.
and if you can build it to the standard, to the level of, limits of current technology, which also change over time, that you can make sure, you're going to always have a robust product at the lowest cost. So that's what the whole point of reliability is: have a robust product at a very cost effective price.
Yeah. So for our, this note I got, and for others that are facing it at the moment, and it's little solace if you don't have a good program in there and a robust product. So that learn from it, help your organization learn from it, and prepare for the next shock to our systems. Because it's going to happen. And we've
It
had so
is.
many in the last 10 years, it's unbelievable. And
Yeah.
so it's something to think about. Get ready to go. And if you got questions about that, if you have ideas of how you and your organization are dealing with all these changes and uncertainty, or if you've got some ideas or suggestions, maybe we missed a couple of ideas. Kirk and I tend to talk about electronics more than most anything. But if you're mechanical or software or whatever, we got some ideas on it, let us know. Head over to accendoreliability.com/go/SOR, and you can find a couple of ways to get in touch. Kirk and I and the other hosts of the show are available through LinkedIn and our About pages. So plenty of ways to get in touch, and we look forward to hearing from you.
That's right. We love those questions, and hopefully we hit on a topic that you're really had to deal with or going to have to deal with in the future.
Yeah. Oh, that gives me an idea for another episode. You got some time to record another one, Kirk?
Sure.
All right, here we go. Thanks much, Kirk. We'll talk to you
All
real
right,
soon.
Fred. Talk to you later.
Yeah. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.